stay tuned. So let's welcome our next speaker. I'm praying that I'm pronouncing his name right, but he's backstage, so hopefully he will correct me. Hakon Crow, hopefully. So Hakon works for Crystallize.com, and his talk today is titled How We're Running Crystallize.com on Turbo Mode Using Next.js. Hakon is a front-end developer at heart with a passion for performance and outstanding user experience. He is head of engineering at Crystallize during the day, pushing API performance and developer experience. And at night, he is nerding out on new web APIs, protocols, and tech. So also, actually, I'd like to tell you about 2 previous talks he's done. In 2019, he spoke at React Amsterdam on the uncanny valley in React. And then also in 2019, he spoke at React Norway about high-performance React e-commerce. So I'm about to pull him up on screen. So like I said, let's give him a warm welcome. Hi.
Hello.
Please tell me I pronounced your name correctly, please.
It was about like 90% correct.
Really?
So
okay, how do we...
It's a pass.
It's a pass? That's good.
Yeah.
What's the correct way of saying it?
Håkon.
Okay, I wasn't even close. I'm so sorry.
Oh, come on. Give you some credit. It was good. I've heard way worse. Way worse.
Well, thank you for being patient with me. I will pronounce it correctly from now on. Håkon.
That's very good. Yeah.
Thank you.
Almost native-like. Yeah.
Wow, thank you. So how are you feeling today?
I'm good. I'm psyched.
Yeah?
I've been waiting for the festival for some time now. I'm got some really interesting things, I hope, to share, and really enjoying the online format. I mean, a physical conference has its perks, but then online has different ones. So I think it's a very good thing.
I think one of the biggest benefits that I can say from just our experience here at Geekle is we're able to reach a much wider audience. And that's so beneficial because truly you can be anywhere in the world, pick a time that's convenient for you and your time zone, unlike me, who's going to be here until 2 a.m. And you can just tune in, and it's truly amazing. I think it's there's not many good things that came out of COVID, but I think this is one of the few things that truly has been a very positive change, in my opinion. But anyway, I won't take up too much of your time. I could just sit here and talk forever. So we will see you again at the Q&A, and obviously I'll see you at the end of your talk. So I'm going to pull up your presentation on screen, and I'll let you get on with it. So good luck.
Thank you very much. Okay, I guess we'll talk later then. So, hello everybody watching. I have been working on my presentation for some time, and with great pride this time I can say it's only been me. I haven't had my head of design with me, so my apologies for any weirdness and the visuals. Anyways, let's get to the case. I am working for Crystallize, as previously mentioned, and the talk today is going to be about how we're running Next.js in turbo mode. So let me give you a brief introduction before I begin. This is the team of Crystallize, and that's me at the very end there. I am the head of engineering, trying to lead a brilliant team of skilled people, and we're trying to establish a new kind of business model out on the web, which is headless e-commerce, which is a very popular thing these days. I've been a front-end developer for a long time, 10, 12, 13 years or so, pre-jQuery days. I remember the introduction of jQuery as being something really big, and that was going to save everybody, and it did for some time. So anyways, that's me at work, and this is a picture of me at home when I'm not working, trying to teach my 2 kids how to do skiing. I live in Norway and we have snow, lots and lots of snow. And skiing is one of the essential things you need to know how to do. In fact, when I was a kid, I had to ski to school sometimes because you couldn't bike and there was too much snow for the cars. So now you know that. This talk is about our website, Crystallize.com. It's, as I mentioned, we're a software as a service. I'm just going to give you some context. We want to be a headless commerce toolbox, and we're both a PIM and CMS, just to throw all the abbreviations out there. Essentially, we're something that can enable you to build a shop or an app, something, website, app, whatever, that can sell your products. And to build Crystallize.com, we looked at a whole bunch of different technologies. And from all of the things that you see here, we're going to ended up using none of them. In fact, most of the tools that you see here, or frameworks, libraries, call them what you want, would in fact slow us down more than help us. So this talk is going to be of neither of them. We're not going to talk about them. We're going to talk about the bare essentials of web and how they help us maintain super performance. Let's get to business. Crystallize.com. So before we dive into the code and the performance and all the details, I want to give you a bit more context of what we're trying to do. So for our website, we needed to know before we started 3 years ago, we had to ask ourselves the question, what should it do? Well, it's mainly two things, and one of the first one being marketing. It's the go-to place to find out about Crystallize. It should promote our product well. And the next thing is documentation. So once you know the product or get to know the product, you probably want to know how it works. So it should also work as that. So it's marketing and documentation. How should we do it? Well, there's essentially two things we wanted to do. First of all, it should look good. It's like stunning. We want a very unique identity, which is why we have our own illustrator who draw this wonderful drawing of the man here being so amused. So that's rule number one, which trumps everything. It should look good. Second, it should be fast. Fast is kind of the mantra of Crystallize. We're software as a service, and the API that we deliver needs to be fast. And I'm talking fast. I like proper fast. Not just your average fast. I'm talking fast. So we had to figure out what that meant for us. I mean, what is fast? Is it just, being faster than your competitor? Is it being fast at the marathon, or is it being fast at the 100-meter dash? What is fast? So in order to answer that question, we had to find out who our target audience would be. And I'm not going to spend too much time on these details. I'm just going to run through it quickly. So typically, it would be someone who is in a website for 2 to 5 minutes, looks at probably less than 10 pages, and reading about our product or documentation. Pretty much it. Okay, so knowing the target audience, we can then box them into one of two categories. Is it the load performance that we're interested about, or is it the runtime performance? And what's the difference? So I guess you would imagine load performance as the initial boot up of the website. Like how fast does it take to images to show, the font to show, the layout to be painted? That's the load performance. And the runtime is sort of everything after that. How fast does page navigations take, any interactions, any state updates, and so on and so forth. But given our target audience, who don't really spend a whole lot of time on a website, doesn't look at a massive amount of pages, essentially just reading and scrolling, it's kind of obvious that what we're looking for in our website it's load performance. And this matters the most. So when someone is interested in reading about our product, they should get the page served immediately, fast, and don't have to wait for things to load. Runtime is more critical to a different kind of website, like our back office application, which runs for hours and hours. The sessions are really long and they visit hundreds of pages. Then that's more important. And I guess we also have to answer the question, why we want to be fast? Why do we want to be fast? Well, it's an obvious question. It's an obvious answer to the question, isn't it? It's happy visitors. The faster you are, the happier the people. You're right. That more pleasant experience. The faster the sites, the less bytes you download. Potentially, usually at least. That's how you make a fast website. So the less bytes that download means you get a cheaper phone bill. Hey, that matters to some people. And it's one of the reasons. It's definitely one of the reasons. It's not the reason. It's not the top reason, actually. Nope. Could it be environmentally friendly? As I mentioned, being fast typically means you download less bytes. Okay, and that means we transfer less bytes over the wire. But, there's less work to do for the proxies around the world, less work to do for the CDNs. There's actually less to consume by the device that you're using, like your cell phone, which means it's using less battery to do it. And that's better for the planet. It's one reason, yes. It's not the reason. So to get to the brutal truth of why we wanted it to be fast, the number one reason why we needed to be fast, it's search engine optimization. SEO. It's not always the argument when developers advocate for performance, but for us, this is the number one reason. And why? Well, if you've been paying attention to what Google has been doing for the past few years, you might know. So back in 2018, they were on about that speed now mattered in mobile search ranking. So if you're slow, that's not so good. And then later on, in a couple of years later, to 2020, they announced that the ranking signals would matter. Essentially, the metrics that they pull, the speed that they measure from actual users will matter in the ranking. This is critical stuff. And in this, you can read 3 very important words in its core web vitals. And for those of you who doesn't know what the core web vitals are, let me give you a quick run through. It's 3 metrics made up by the Chrome DevTools team, or I think DevTools team, I'm not sure. It consists of 3 metrics here that are something which should be reasonably easy to comprehend and to measure, at least. The first is LCP, largest contentful paint, which is the largest contentful paint on the screen. Essentially, the moment in time when the website looks like it's ready-ish of booting, or the largest part of the booting is done. And everything under 2.5 seconds is good, and the rest is bad, essentially. And the next is the first input delay. Again, this is very much something that the users care about. It's how long delay is it for the first interaction. So immediately after the website is loaded, the user might try to click something. And if there's a delay from the click to the action, that's your first input delay. And obviously, any delay is bad. If you have someone click a button, for instance, if you're landing on a product page and there's a huge buy button and you try to click it and it doesn't work, that might be because of really long first input delay, and it's bad. Very bad for an e-commerce. And would be for us too. We don't want to have frustrated users on our website. And the next and last part is the CLS, the cumulative layout shift. Very fancy name for measuring the stability of the layout. Essentially, if you have things moving around because you've got images loading, which pushes content down, for instance, or if you have a web font that loads in late that changes the size of the text, then the layout will jump, and the user might lose their position where they were at when they were scrolling. Super annoying. So if that happens, you'll get a penalty for that, and then you can see that in the CLS metric. Okay, core web vitals. So all of them are in the load performance arena. If you go and look back, you can see that all of these matters in the load scenario, which means we can use it as a way to audit our own website. This matters to us. We can use the core web vitals for Crystallize.com because this matters a whole lot for what we want to do. So how do you test it? How do you measure it? Well, you could do a quick Google search and find out. There's usually some brilliant people that can answer it. Essentially what you need to do, sorry for that last one, what you need to do is to use Lighthouse. This is a Google tool. It's in Chrome in DevTools. You can open the performance panel and do an audit on your current website. But if you haven't done that, I suggest that you instead go for an online tool like PageSpeed Insights, which is using Lighthouse to do a performance audit on any given website, which is really cool. And it's really simple too. You just input the URL, wait a few seconds. Now we're testing the conference website. I'm sorry. I didn't want to test around my website just now. I'll do it later. So for now, this is the conference website, and it's not scoring very good, but that's okay. I can help you make it better, but I think you know too. Anyways, you get a single score back, and you can see from the information below that anything from 0 to 49 is in the red zone. 50 to 89 is in the orange zone, and only 90 to the 100 is in the green zone, which makes it really difficult to get to the green one. It's also very, very hard to get to 0. I have to tell you that. I think I've seen 5s and 6s and stuff. I haven't ever seen a website score 0, so it's practically impossible. But as you can see, it's a single score you get back. And I just have to admit that this is a wonderful resource for developers. Having a single score represent the performance, well, load performance of your website. It's a wonderful tool for you to use to people that don't understand the fundamentals of web. You can't go to a project manager and say, hey, our first contentful paint is not where it should be, or the CLS is bad. No one's going to get that. But you can show them this and say, hey, we got 24 out of 100. We should do a lot better. We should be at 90 at least. It's a lot easier to communicate. So I truly love this, although it simplifies things a whole lot. Still, it is very valuable. Everyone in the chain gets this. You're getting 2 scores back, desktop and mobile. These are just simulated. They're called lab data. And the reason why you're getting different results is because, well, a desktop machine is more powerful than a mobile phone. So the first contentful paint is always going to be faster because it takes the desktop shorter time to paint, essentially. All right. Enough background already. Let's get to the real juice. Let's look at what our first attempt of making Crystallize.com. And finally, we get to see some actual stuff. Okay, so back in 2017, we got real creative and we came up with the first version of Crystallize.com, which looks like this. And it was beautiful. We were really happy, and it was a Create React app with a custom SSR rendering running on AWS Elastic Beanstalk is a mess of a setup. But it worked. And it was beautiful. It checked the first box. It was stunning. We loved it. Until we did a performance audit. So we ran it through Lighthouse, through PageSpeed Insights, and we got this result back. Look at this. I mean, our largest contentful paint is 13.6 seconds. This is mobile score, but 13.6 seconds. That's a long time to wait for Crystallize. I mean, even I would be impatient. I mean, if you don't even know Crystallize, you would leave way before that happened. The 15 seconds the time to interactive. Oh, obviously, we needed to do something. So it was time to roll up our sleeves and grow up and get to work. So the first thing we did was scrapping our Create React app, and we went for something which at the time started to look mature. That was Next.js. So it was a performance ready. So we were hoping that we could, apply Next.js, and this is more or less what we did, to get from here to here. And now I will be showing you 5 take-home tips plus a cheat at the end that will help you do the same if you're struggling with the same stuff. And the first take-home tip you can take home with you is this: design for performance. And the reason why this is number 1, it's because it's the most important one. Without a proper design as a foundation, you won't be able to have good performance. I brought in the head of design, Didrik, that's that dude, and we came up with the current version of Crystallize.com, which is a whole lot easier to optimize for performance than our previous version. The desktop version looks like this. The mobile version looks like this. And if you look at both of these versions, it's pretty much, there's some text, there's some buttons, there's a custom font, sure, but everyone has that. And there's a simple illustration, which is kind of vectorized, so it's easy enough to optimize. And the mobile version doesn't even have an image at the top here, so that's easy enough to do. Well, it has our logo, I guess, but not more than that. So this is rule number 1. So we applied a simple performant design, still beautiful in our opinion, across the entire site. So if you want to do the same for your own sites, you need to start here at the design. This is where everything is, the foundation is laid here. So the second take-home tip is you have to tailor-make your CSS. We had tailor-made CSS. So this is the second one, and that essentially means no material UI, no ready-made framework that has all the buttons and layout and all that. It is easy for you to make a website in using one of those libraries, but it won't take you all the way in terms of performance. If you want top-of-the-class performance, you have to scrap those libraries and tailor-make it yourself. We chose style components for our website, as a lot of people do. And if you're not familiar with style components, this is how you do a simple button. Essentially, you're tying the styles to the component. It's an explicit binding. And that, to me, is a beautiful, beautiful thing. Because having the explicit binding for the styles to the button means you can always have confidence that when you import something, the styles will follow along. And if you remove that component later, you know that the styles for that component will also be gone. And it will also, boost confidence when deleting CSS, because you can be quite confident you're not deleting CSS that anyone else is relying on. So to me, beautiful, beautiful thing, which leads me to the next take-home tip, which is really cool. I really like it. It's critical CSS done in the proper way. Now, for those of you who haven't heard the term before, critical CSS means sending the CSS that you, at the bare minimum, need to paint your layout alongside your HTML or inside your HTML payload. Let me explain what that means. So back in, well, traditionally, you have one separate HTML file for your HTML. You have a separate file for your CSS. And in the HTML file, which is the big box here, you would say link to a style sheet, which is called style CSS or something. And then the browser would then parse the HTML document and then download the CSS file, which takes a bit of time. And if you want to save time, you don't do it this way. You do the critical CSS way, which is move the CSS into the HTML. It's simply now just a style tag with the styles that was previously in the outer in the external file is now just inlined in the HTML. It makes for a faster initial load, simply put. Fortunately for us, with style components, this is super simple. It's not an elaborate thing we have to spin up later where we, and these I've seen tons of implementations like this where you spin up a browser session that looks at your website and tries to pull out the styles that are the critical ones. You don't have to do that. Using Next.js and using style components, this is all you need to do. And yeah, it's a bit cryptic, but this is basically just a copy paste from the example, which you can find at the Next.js GitHub repository in the examples of how to use style components. And there are other examples for different kinds of CSS and JS libraries too. But this is all you need. And what this does is that it pulls out all the styles that your current route is using. So for instance, for the front page, this is pulling out all the styles of all the components being rendered, even down to the footer, everything. And you might think, well, that's a bit too much. But nah, you're going to be fine. It's not going to be massive. It's as long as it's tailor-made and as long as you're in control of what you're rendering, it's not going to be a problem whatsoever. Great. And obviously, that means that when you ship this inline CSS in the initial HTML payload, there's still going to be a JavaScript file, which Next.js so helpfully gives you later, which will contain the same CSS as you have in the payload. Just kind of a double download. And then for the subsequent pages, for instance, /blog, will contain the CSS and JavaScript for that. But hey, it doesn't matter much, believe me. Okay, the next take-home tip that we did, you should all be doing if you're doing Next.js is static site generation. And essentially, it just means that you, instead of rendering the pages on the fly, you do it in advance. You build all your pages in advance. And there's a lot of good resources you can read about this technique. Essentially, all you need to do is to define a get static props function on your page component itself. And this is a pure copy, a raw copy of how our front page declares its data dependencies. So it has a get static props function, and note the name static. If you don't want it static, you can use get server-side props, for instance, and then it's server-side rendered. Next.js is wonderful that way. Really, really nice. So initially, what this does, it moves your page or your application from being server-side rendered, which is it's taking some time. So server-side render means that, well, you have to boot up a node instance, and that node instance has to be warmed up, and then it has to receive the request, look at which route to load in those JavaScript files, pull the data in, render the page, and ship that HTML back to you. It takes about 1 to 1.5 seconds, more or less. But with the static build, you're reducing this time to 100 milliseconds or less. We're seeing an average between 50 and 60 in our case. This is running on Vercel, but essentially the reason why it's so fast is that because it's static, it's already in the CDN. The HTML files are ready. The CSS, and obviously that's in line with the JavaScript, and that's ready. We're just requesting files now. There's nothing that needs to be rendered. And obviously the beauty of that is that we're going to be fast around the globe. There's no need for us to have a server in Rio and one in Tokyo and one in Frankfurt. We just put it on the CDN and we distribute that around the globe. If you're running Vercel or Next.js on Vercel, this is going to be automatically applied. You don't have to worry about it. Your website is going to be fast around the globe. And the last bit of the static thing is this one. Incremental static regeneration. Oh man, it's a long word. Very cryptic. Some people just now refer to it as ISR. I don't like abbreviations, honestly. I like saying it like the whole thing instead. And what it means, and I'm going to let my illustrator Bartosz try to illustrate it for you. Incremental static regeneration means, first off, when a user comes to your CDN and asks for something, like a product page, the CDN will just grab one, like a pre-built one, and just ship it to you. This is pre-built. All the CDN needs to do is to find it in the stack and give it to you. And the incremental static regeneration means that in the background, while the user is reading this wonderful product that you built, it regenerates the product page. It reads from whatever API you might have been using, and it puts that brand new product page back in the stack and gets rid of the old one. And when a new person comes along, requests for the same page, that person is going to get the new one. It's a wonderful, wonderful thing. So you don't have to worry about rebuilding your entire site. It's going to happen on the fly. And this is something you can enable really simply. And it works out of the box with Vercel. And all you need to do in Next is take your, remember this is our front page. So all you need to do to enable this is add this single line. See the difference? We have revalidate equals 1. Previously we didn't. Now we do. This one, no incremental static builds. Now we do. It's a wonderful little thing. So yeah, the next take-home tip, just kind of take a breath. Self-hosted custom fonts. Fonts are always a bitch. I have to say that. It's no fun. We are going, as a lot of other people doing, we're using Roboto as our custom font. And if you go to Google Fonts, which most people do to find their fonts, you can see, oh, there's a nice little link here with a pre-connect and stuff like that. It looks optimized, right? It even has that cool display equals swap, so that will be fast. No, it won't. So in order to have proper performance, we decided to inline our fonts along with the HTML response using font source, which is available on NPM. You can do that. Just download the font using them like this. You have this in our app.js file, and you're good to go. That's it. So by applying all of these different techniques, we were really psyched. Like we got Next.js, we got all the font loading, we got the critical CSS, we got static builds and all. We were like, okay, what's the results now? Like, how does this perform? And we were running an audit using PageSpeed Insights, and we were ready to pop the champagne when we saw this number, 78. It's obviously far better than 30-something. But we really wanted to get into the green zone and to 100. to be honest. So what were we doing wrong? So when we looked at the lab data, we saw that the largest contentful paint was still a bit much, and the total blocking time too was a bit much too. So we started to look at what we were sending the client. We looked at the HTML. So this is the HTML for any page. It contains our inline CSS, you might recognize that, the HTML, and then at the top there's preloading scripts, and at the bottom there's scripts, and in between that there's application state. It's a whole lot of extra stuff, isn't it? It's essentially what React needs on the client side to sort of recreate that entire HTML document. It needs the scripts, it needs the application state, and with those two combined, it can recreate the HTML and sort of rehydrate your app. Fair enough. But just a whole lot of stuff. And we thought, hold on, what do we really want to do? In a perfect world, this is what we will ship the user. No preloading scripts, no application state. So we were thinking, what if we get rid of them? How wonderful wouldn't that be? So we did a small, really quick test. You can do this too. Open DevTools, open the command palette, and disable JavaScript. It's a fun experience. You can browse pages, you try different websites and see how good or poorly they're working with that JavaScript. But for us, we saw that when we turn off JavaScript, the total download size went down from 2 megabytes to 1.2. And that 1.2 is still including a massive amount of application state. So it was becoming quite obvious to us that, well, when back in the days, JavaScript was just one piece of the puzzle. But now, in 2019, when we made this comic is just as valid today, looks like JavaScript is becoming its own very big monster and its own kind of puzzle. So we had to ask ourselves, why do we even need React in runtime? What are we using it for? So we had to look through, and it was a few things we used it for, the menu being one, this forum here, book a demo. We had a carousel with some videos. So we thought, we want to do this vanilla. And this is your final cheat. Do it vanilla. What does that mean? Well, it means you have to turn off React runtime. Like, what? Yes, you have to turn off React runtime. And fortunately, using Next, it's simple enough. Remember this page? You just add this. It's an undocumented feature, but Tim Nutkins from Next team, he won't hesitate to tell you how to do it. He keeps going on about that on Twitter. So this, by saying unstable runtime JS equals false, it will take away that application state. It will take away script preloading, take away scripts, and then all you're left with is your HTML and your CSS. And you're on your own. You're totally on your own. It means removing stuff like useState, because there's not going to be a useState. There's not going to be effects, so we can remove all use effects too. So for us, that meant we had to redo some of the stuff that we had in React and do them in vanilla. So that meant our main navigation changed from, and yeah, this is how it used to work. This is more or less how we did it and how most people would do it. Simple state, which we changed to this. It's still the same stuff. It's a main nav and a button. They just have IDs now. And this is the vanilla JS that you need. And honestly, it's not a whole lot. And if you ask me, this is perfectly understandable and maintainable. You see that we have a classless toggle open, which essentially means that we will remove and add an open class to the navigation. And the way that we specify this is that, well, we're using style components. So you can still use style components with this approach. So the at.open means that if the nav has a class called open on it, it will say display block. Simple? I think so. And the cool thing about that is that then you can apply all of the cool stuff that you want to do using style components, stuff like transform and scale and all that stuff, transitions and animation, keyframes, you name it. Things that you can or will not do with inline styles. The second example that we do, so this is the easy one. This is the more difficult one. It's the playground. So Crystallize, we offer a GraphQL server to people. And on the website, we wanted that GraphQL server to be played with, simply put. You can try it out. It's on the developer page today. You can go in, try it out, modify fields and see how fast our API is. I mean, we wanted that. And that sounded simple enough, right? Well, it's powered by a tool, a framework called Graphical. And you think, okay, cool, but that's, not a big deal. Well, if you look at what it requires, yep, React. We turn off React. But this tool needs it. So we had two options. We could either turn back React runtime for the pages that use the playground, or we could continue to do it vanilla. We chose the latter. We did it vanilla. And this is how we did it. Essentially, let me break it down here. We're adding two dependencies here. This is loaded lazily after the page is loaded. It's the graphical CSS that it needs and React core. So we're downloading a new version of React. It's totally independent from whatever Next.js ships. And this is just our approach. This is one way of doing it. And then we have the second part here where we're sort of waiting for React to be available in the window object. And then we inject the last bits. And then if you wanted to know what the wait for React function does, simply this, not really magic to that. And to initiate the graphical playground, all you need to do is this: React render React rate element, and so on and so forth. Not really rocket science if you look at it. If you go back, we're just loading some scripts, steps, and then booting up the playground. It doesn't have to be more difficult than that. So the total download size went down. This is actually wrong. I forgot to update this. It's less than a megabyte now. We're down to 400 or 500 kilobytes. Oh, wish I had updated that. And the total client work went down from 270 to 0 milliseconds. So the results, well, remember this score? I think you might know. We got this almost consistently.
Hi, sorry to interrupt. We've run out of time, so do you think you'll be able to wrap up in the next couple of minutes?
I am.
Perfect. Okay, sorry.
At the very end.
Okay, great. Continue.
Nice. So this is the front page. This is one of the blogs that we have. We're seeing consistent runs between 99, 98, or between 98 and 100, essentially. And this matters to us because we will rank really high on the things that matters to us. So headless PIM being one of them. We want it to be at the top. You can try yourself. We want it to be at the, very visible at the developer comics and Google image results, which we are as well. And if you're curious to do the same thing, if performance matters to you, if you want to rank high or have an environmentally friendly website, or have happy customers, or cheaper AdWords, which is one thing as well, then all you need to do is turn on this flag. And this is a page, per page kind of thing, which means it's not application-wide. You can actually turn it on for a certain number of pages only. You can start with one. So this is how we do it. We have the runtime turned off for the home page, each blog post, and each comic, but not for /blog and not for /comics. They are scoring decently, but not as good as the other ones. And we kept the runtime for blog and comics because they are actually doing a whole bunch of intricate React stuff with paginated list with infinite scrolling and stuff. So you can still have that. But for the critical pages, we turn it on. So this is what I hope that you can take home with you today. There's a lot of cool frameworks out there, but essentially, if you want to do it good, you have to do it tailor-made. So that's it. It's a wrap.
Thank you so much for your wonderful talk. That was very, very engaging. Some people are saying they like the comics. I like the comics as well.
Yeah.
So wonderful. Great. Then I'm sure there will be a bunch of questions for you coming soon. And I will see you very shortly at the Q&A.
Yep.
See you soon. Thank
Yeah.
you.